first thing we did was we watched the review of the last lesson, and all we did last lesson was we said, okay, we have our box with our element symbol in it. The top is the atomic number and the bottom is the atomic mass. The atomic number is the number of protons. Why? Because it never changes, okay? You have a nucleus and nothing can get in that nucleus. So the number of protons and neutrons never changes unless it's an isotope, okay? Then you have the electron cloud outside. That's the number of electrons. So when I was asking you, okay, carbon, how many protons, neutrons, and electrons? Okay, whatever carbon's atomic number was, that's the number of protons. And then the number of positive protons always equal the number of negative electrons. So on a neutral atom, where things do not have a charge, the number of protons equals the number of electrons. Only when they start giving us a number in the corner, like this for the people who are out, or something like this, +2, they're telling you that there is a charge difference. But look up here, you can't get into the nucleus, so the protons never change. It's just the electrons that can change for the charge difference. Okay, here is her lecture. I'm just going to open up the PowerPoint and I'm going to lecture the PowerPoint. Okay, so it's called cations, anions, and their abbreviation. Okay, an atom, what is an ion? So this whole unit is about ion. Think of I'm turned on. There's something turned on. So when there's a positive in the corner, +1, +2, +1, +2, or a negative, that is not neutral, it's turned on. Okay, so an ion is when there is a charge. An atom or a group of atoms that has a positive or negative charge. If they don't give you a charge and you look and the number of protons and electrons are the same, it's neutral. That's fine, okay? Ions form when an atom gains or loses electron. Can it ever gain or lose a proton? Can it ever gain or lose a neutron? Those are in the nucleus, okay? You can easily steal electrons. You could easily give electrons, okay? If anybody has a balloon and you get some static electricity charge, you just stole a whole bunch of electrons from somebody's hair. We can easily pass electrons from one person to another or one atom to another. Okay, how to write ions. An ion, ionic charge is written as a positive sign or a negative sign followed by a number. If you would ever get like a B and then a plus, it means a 1 behind it, but it should always have a number. So it should be like B +1 or B -1. Whenever they tell us a plus or minus, we know it's an ion. There's a difference in protons and electrons. The number represents the amount of electrons gained or lost. Okay, cations, okay. An atom or group of atoms with a positive charge, metals lose electrons to become cations. I'm not going to test you about the metals. Cation is something with the positive in the corner. So cats, yay, we love cats. They're a positive thing. We also love Caterpillar brand excavators and stuff. We love Cat 9 baseball bats. Cats are great. They're positive. Anything that's positive is a cation. So here's our example. So ready? Have the same name as the element that forms them, but different chemical properties. So sodium, cation. So it's sodium, cation. Calcium, cation. Okay, so if it has the pluses, you know it's an ion and it's a cation. Okay, what happens when there's negatives? Atoms or groups of atoms with negative charge are anions. Usually non-metals tend to form ions by gaining an electron. Think of anti, angry, antagonist. All of those mean negative characters. So it's the negatives, okay? It's gaining electrons, so we'll talk about that. Cation positive, anion negative. So here's some examples. The name of the anion is the element with "ide" on the end. So for oxygen and chlorine, when they become an anion, we call it the chloride anion or the oxide anion. So I know that it has little bullets here, but it's just O minus 2, Cl minus 1. Okay? Okay, so this is a way for you to remember how do you know if they gain electrons or lose electrons. But first of all, if you know that electrons are negative, if you gained more negative electrons, should your charge be more negative? Yeah, you can't take on more negative and become positive. That doesn't make sense, okay? So this is their example. And also you can say, if you have negative friends and you get rid of your negative friends, you become more positive, okay? So ready? Ion formation is like dieting. Losing electrons, you lose weight. Ooh, that's a positive. Gaining electrons, that's a negative. So this is another way to remember them. Also, for the people who were out yesterday, so for boron, there's 5 positives and 5 negatives when boron is just neutral, okay? So it has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, they cancel out. They all cancel each other out, okay? Well, what if boron steals another electron? Okay? When you take another electron, you become more negative. So this is boron, negative 1. So cancel out, cancel out, cancel out, cancel out, cancel out. Oh, I have 1 extra. So this must be boron with an extra electron. So boron has 5 electrons, and now it has a 6th. 1, 2, 3, 4, 5, 6. Perfect. Okay, here's the tricky part. What happens when it's a boron plus 1? Can we ever add a proton? No, protons are in the nucleus. So you have to lose an electron. You lose weight is a positive. You lose the electron. You lose those negative friends, you become more positive. Now, 1, 2, 3, 4, 5 positives. 1, 2, 3, only 4 negatives. That's where it's now overall positive 1. Okay, so when we do our practice at the end, I can't remember if we finished all 4 or not. I think we just did the first 2. We're always going to count how many positives, how many negatives. Okay, so this is a little bit different. So let's do beryllium here. On the periodic table, it normally goes 4, beryllium, 9. Okay, also I want to point out this first letter in a symbol is capital. That one is always lowercase. So y'all look at number 17. That's chlorine, Cl. What about 81? What is that? TL. So it looks like TI, but no, that's TL. TI is 22. So remember, every second letter is always a lowercase. Okay, so when we do abbreviations, we switch them. So the 9 comes up here, the 4 comes down here. So this always here is the atomic number. So the atomic number is always here at the bottom. Here's the mass. And then the atomic mass switches up here. And then this is the charge. Okay, when there's no charge, it means it's neutral. Or when you count the protons and electrons and they're the same, it's neutral. This one is not neutral. Okay, almost done. Okay, this is where we stopped. Did we finish? We finished?
We did 2 with you and 2 on our own.
And then you checked it.
Did I really? Oh, and I
Yes.
checked it at your seats? Okay. So this is what I'm going to do. For anybody who is still confused, I'd like you to watch me do all 4 of these with the 2 kids who are absent. We're going to do all 4 again. Who is absent? Just 1. And pass back to Peyton. Okay. Everybody else, y'all are going to get a worksheet. It's going to have half neutral atoms and half ions. Oh, lovely, here they are. Okay, so y'all, everybody at the top, it's called connecting neutral atom chart to ionic atom chart. So both of these charts look the same, but the only thing different is I'm telling you, all of these up here are neutral. So if they're neutral, the number of positives equals the number of negatives. We're not stealing electrons. This is just easy. This is the way we learned first. Then on the bottom, I wrote ions, okay? So you will have a difference in the number of protons and electrons. Hint, hint, there is one where it is neutral, and you're like, Miss Weiss, it says the electrons and the protons are the same. Do you think if it's neutral, we need a charge? No. So if you actually are on the ion sheet and it actually tells you it's neutral, you just leave it blank. That's fine. Okay. Also, last thing, it has completely blank slots for 3 of these. It has a -3, a +1, and a +3. Do these instead. So make the one that says a -3, P -3. Make the one that's a +1, H +1, and Al +3. So y'all are doing this independently. If you need a calculator, if you need a periodic chart, come up and get one. You're not doing this with a partner. If you have questions, you can ask me, or if you're struggling, you can listen to me do it up here with the kiddos who are out. Perfect. Okay, for those of you who are out. So, first off is, you can't do any of these unless you know what element it is. Now, they told us this one was sulfur, okay? And they told us this was calcium, but we don't know this one. How can we figure out what this one is if they give us an atomic number? Yeah, so what's number 7? Nitrogen. Perfect. So I'm just gonna put, actually, we'll start off with sulfur. 16S32, 16S32. We just said nitrogen 7, nitrogen 14. How do I know what this one is? 17. Cl, so 17Cl35 chlorine. And then it tells us calcium, and that's 20 calcium 40. Okay. So, this first one. Remember, first thing we have to do is we have to, in the element abbreviation, switch. Okay, so the 16 comes down here, the 32 comes up here. Okay, so now it's 32S16. They gave us this, so we're going to play with the electrons later. Also, guys, if anybody's stumped over there in blue, I wrote, if you need help, go through these steps. It kind of tells you, okay, first off, make sure you got your element. Second of all, make sure you fill out everything. And then third of all, that's how you check the charge of the electrons. So if you're stumped, go to the blue. Okay, so based on its regular box, my atomic number is 16. My mass is 32. Okay, my atomic number is always my number of protons. Okay, you don't have to do this, but I'm gonna do this just to remind y'all where you're looking for the charge difference. Protons are always positive, so I'm just reminding you, you have 16 positive things. Neutrons, that's the atomic mass minus the atomic number. Okay, so it's the big number minus the small number, 16. Okay, now, we need to figure out how many electrons if they're telling us sulfur has an overall -2 charge. If it was even Steven, there'd be 16 positive and 16 negatives, but they're telling you there's 18. Good, there's 2 extra electrons, so -18. And y'all, if you would do that, +16, minus 18. Perfect. Overall, -2. Y'all got it.
I have a quick question.
Yep.
On the neutral chart, do we still write a negative next to the electron number?
You mean like right here? Like how I do it here? Only if you want to. Hey, that's a question. Good question. I just write the positive next to the proton so y'all remember it's positive, but I won't take off.
I just make sure.
Yep. Okay, so let's do this next one. So we have 7 nitrogen 14, but we got to flip it. 14 nitrogen 7. And we do not know what the charge is yet. Okay, my atomic number is 7. My atomic mass is 14. My atomic number is my number of protons. My neutrons is basically big number minus small number, 7. Uh-oh, they gave us -10. So we have 7 positive protons in the nucleus. That will never change, but now we have 10 electrons. What's the overall charge? Boom, y'all got it. Okay, next one. So we're gonna flip it. 35 chlorine 17. Don't know the charge. 17, 35. 15 minus 17, 18. Okay, what about this one? Plus 17 minus 18?
1.
Positive 1, -1.
Negative.
Yep. Last one. 20 calcium 40. Switch it. 40 calcium 20. Oh, this is a good one. It tells us to make it negative or +2. 20, 40. That's a +20. 40 minus 20. Okay, what do I do with the electrons? How do I make it an overall +2 charge, but I can't add protons? I can't change my protons. What do I have to do to my electrons?
Take away.
Good. So how many? What number? Do you agree? So if I do a -18, would that mean that there were 2 more positives?
Yeah.
Yeah, awesome. Y'all think you got it? Okay. If anybody has questions, call me over.